Now that we have talked about the different parts of a polynomial and what exactly like terms are within a polynomial, we can now talk about adding and subtracting polynomials. So let's first look into adding polynomials. So to find the sum of a polynomial, you just need to identify and combine like terms that have the same variable and exponent. You can think of it as like a sorting task. You want to group matching powers together and add their coefficients while keeping the variables and exponents exactly the same. So taking a look at example 1, we're asked to simplify the following expressions by combining like terms. A note here, we are also asked to leave our answer, oops, I don't want that one, I want the highlighter. We're asked to leave our answer in standard form. So taking a look at example 1, we have 3z to the 4th power plus 2 plus 4 plus 2 plus z to the 4th power. So taking a look at our terms, for this first term here, we have a 3z to the 4th power. So taking a look at the second polynomial, or in this case it's a binomial because it has two terms. Let's see if there's any other like terms. And there does so happen to be a like term because those two terms there, they both have the same variable z and they have the same power of 4. So we can just go ahead and combine those terms. So when we do that, we get 3z plus z to the 4th, which would get us 4z to the 4th. And then this 2 here, we're just going to carry that 2 along, and that's it. Taking a look at example 2, we have x squared plus 2 added by x squared minus 2. So to add these two together, I'm going to identify that both these here are like terms because they both are an x and they both have a net power of 2. And then notice here that this 2 and this negative 2 are also like terms because they're both just numbers on their own. So we can also combine those. So when we do that, we get x squared plus x squared, which is 2x squared. And then 2 minus 2, well, those just cancel. So we get plus 0. So our final answer is just 2x squared. Taking a look at example 3, we have 7y to the 4th plus 3 minus 6z plus 4 minus z plus y cubed. So we got a couple different variables going on here. We have a y and a z variable, but it's something we can't handle. So the first thing we want to do is check for like terms. So for this first term here, we have a 7y to the 4th. Let's see if there's a y to the 4th here in the second term or in this first term. And there isn't another y to the 4th, so this guy has no like terms. So I'm just going to go ahead and write that here. Alrighty, so taking a look at the second term here, this is just a plus 3, so this is a constant. Let me see over here if we have another constant. And we do, we have a 4. So because we have two constants, they're like terms, we can combine those. And then for here, we have a negative 6z. Let's see if there's another z term, another linear z term over here. And there is. So these two are like terms because they have the same power. And then this last term here, we have a y cubed. And there isn't a y cubed over here, so this guy is also on its own. So I'm just going to go ahead. Before we combine any like terms, I'm just going to go ahead and write that y cubed over there. And now that we've identified our like terms, let's do that. So I'm gonna first combine these linear terms, this negative 6z and this negative z here, because recall we were asked to leave our answer in standard form. So I'm just gonna go ahead and do that now to make our lives easier. So I'm gonna go ahead and do negative 6z minus z, and that ends up becoming negative 7z. And then we're gonna do 3 plus 4, which is 7. And that's it. That's your final answer. Now, taking a look at our final example, I encourage you to pause the video and try this one on your own. And let's go through this together. So the first thing I want to do is identify our like terms. So we have a 10 here, and we have a -2 here. Because they're both constants, meaning they don't have any variables, they're like terms. So we're gonna go ahead and combine those. Let's see, for this x cubed here, there's no other x cubes at all here, so that term is just on its own. Doesn't have any like terms. We have a 2x squared here and an x squared here. Because both those terms are squared and they're both x, they're like terms. And then this -x here doesn't have any like terms, so it's just on its lonesome, like this -x cubed. So now that we've identified those like terms, let's go ahead and combine them. So we have a 10 here and a -2 here. So 10 minus 2, that becomes 8. So we have 8. And then I'm just going to go ahead and bring that -x cubed down here. And then we have a 2x squared and a 2x. And that ends up becoming 3x, when 3x squared, my apologies, when we add them together. And then here, we can't forget about this -x, so I'm just gonna go ahead and bring that down here. Now we aren't fully done yet. We have to write our answer in standard form. So to do that, we're just gonna write our answer we're gonna write our exponents increasing or decreasing from left to right. So when we do that, we're going to have -x cubed plus 3x squared minus x plus 8. And that's your final answer. Alrighty, so now let's talk about subtracting polynomials. So subtracting polynomials follows the exact same logic as addition. However, we have one more critical extra step that we have to worry about. And that is you must distribute in the negative sign to every term within the parentheses. So in other words, this effectively just flips the sign of each term. And then once you do that, you can just combine like terms as usual. So taking a look at example number 1, we have 3z to the 4th minus the whole expression 2 plus 4z. And notice that this expression here, this example, is the exact same as the one up here. However, we're just subtracting. So let's see how this problem, let's see how our answer changes when we subtract. So recall this negative sign, we're subtracting this whole thing here. So because we're subtracting this whole thing, we have to distribute in this negative sign to both the 2 here and the z to the 4th power. So when we do that, we get 3z to the 4th minus -1 times 2 is -2. And then we distribute in this negative to this positive z to the 4th. It ends up becoming -z to the 4th. And now we can go ahead and combine these two terms, and that would get us 2z to the 4th. And then we're going to go ahead and carry along that -2. And that's your final answer. Taking a look at example 2, let's distribute in this negative to both the terms. And when we do that, we get x squared plus 2 minus x squared plus 2. Now let's combine our like terms. We have x squared minus x squared. Those end up canceling. And then here we have 2 plus 2, which that is just 4. And that's your final answer. Taking a look at example 3, we have 7y to the 4th plus 3 minus 6z minus the expression 4 minus z plus y cubed. So let's first start off by distributing in that negative here. And when we do that, we get 7y to the 4th plus 3 minus 6z minus 4 plus z minus y cubed. And now let's combine our like terms. So, or let's identify our like terms, I should say. We have a 3 here and a -4 here. We have a -6z here. Let me do a different color. We have a -6z here and a positive z here. And those are our only like terms. So let's go ahead and write this out. So we have 7y to the 4th Now 3 minus 4 is going to be negative 1. And then negative 6z plus z is going to get us a negative 5z. And then we have a negative y cubed here. And now our last step is to leave our answer in standard form. So I'm going to have 7y to the 4th minus y cubed minus 5z minus 1. And that's it. Right, so I encourage you to pause the video and work through the final example on your own. And assuming you have gone through it, let's go through this together. So, as always, my first step is to distribute in this negative sign. And when we do that, we get 10 minus x cubed plus 2x squared minus x squared plus x plus 2. Now let's identify our like terms. We have a 10 here, a 2 here. We have 2x squared, a negative x squared, and beyond that, we don't have any more like terms. So let's combine our like terms. 10 plus 2, that is 12. And then we're going to carry along that negative x cubed. 2x squared minus x squared just gets you a positive 1 squared, or a positive 1x squared. And then we're going to carry along this plus x. And now our last step is to just write this in standard form. So I'm going to start with that negative x cubed plus x squared plus x squared plus x plus 12. And that's it.